Okay, so for my Module 4 mastery assignment, I focused on Riemann sums and integration properties. So first is Riemann sums, which can come in either trapezoids, midpoint, left-handed sum, or right-handed sum. So here's just definitions here, but the trapezoid uses the area of trapezoids of each section to approximate the integral. Midpoint uses the middle height of the function in each interval of the integral, and then the left hand uses the left height and the right hand uses the right height. And then here's just a chart showing how to tell if the Riemann sum is over or underestimating the area under the curve based on if it is either increasing or decreasing or concave down or concave up. And then for my example, we have an oil tank is leaking into water. Find how much water after 7.5 seconds using the trapezoid. So here I used the intervals that were already given in the problem to make 5 different trapezoids, and then we use the area of the trapezoid function, which is 1/2 of height times base 1 plus, or base times the height on the right plus the height on the left, and then just add it all together to find the area under the curve. And then in this case, this would be an underestimate of the actual area in the integral, because as you see in this chart, trapezoid, and this is concave down, underestimation. And then this just explains that right here. And then next is the integration properties. So these are rules that guide the combining of integrals, both algebraically and graphically. So here are 6 key integration rules. The first one basically just says that if you have a vertical line, the area is always 0. That makes sense. The second one says that if you change directions, since integrals have a direction from like left to right or right to left, it's the same as the opposite direction but negative. And then the third rule says that the area of if we have C, which is where the function is a constant, so just a straight horizontal line, then we can just use the rectangle formula to find the area. The fourth one says that you can combine 2 integrals. And the fifth one says that you can multiply an integral by a constant by bringing the constant out of the antiderivative sign. And the final one says that you can add adjacent integrals, but it is important to remember that you cannot subtract this way. And then for my example, it is given that the integral, this is hard to see, but from b to c of f of x is 5, a to b is -4, then solve these problems. So first we have from b to a, so that's the same as the negative of a to b using property number 2. Then we have from a to b of 3f of x, so we know we can take the constant and put it outside of the antiderivative sign. So that's 3 times 5 is 15, that's property number 5. And then finally this one attempts to subtract from a to 6 and 6 to b, so throwing a number in there, but we cannot actually use property number 6 here to subtract adjacent integrals, only add. So those are 2 topics that I thought might show up on the AP exam for Module 4.